In today's video, we're going to be taking a look at the source code of DataStore2, ProfileService, and Suphi's DataStore module in order to work out how each one works. So let's first start with the DataStore2 module. So if we open this module, we can see that this is the main part of the module, which contains the main functions to interact with the module. And within this module, there are some sub-modules which the main part of the module uses to work. So let's take a quick peek at the sub-modules. This first sub-module is simply creating a proxy and setting the metatables __ to string to these strings over here. And the next sub-module is not very important. We can just ignore this. And the next submodule is simply taking in an object and checking to see if this object is a player. And the next submodule is an implementation of promises. So if you're not too sure what a promise is, essentially what it allows you to do is say, first do this job, and once this job has finished, then do this job, and allows you to queue a list of jobs to be performed one after the other. But in order to understand how DataStore2 works, we don't need to understand how this promise module works. So you can pretty much ignore this entire module. And I'm going to skip the saving methods and the ordered backup and standard modules. And let's go straight to the settings module. And this module is simply selecting which saving method to use. So here we can see we've selected ordered backups, which is going to use this module to save the data store. And if we now take a look at the table util module, we can see in here there is a function called clone, which does a deep clone of the table that's passed into this function. And if we go back to DataStore2, we can see that there is a function here called clone, which uses the clone function from the table utils to clone a value. And if we search for clone, we should see that the clone function is called when we get the value, when we set the value, and when we save the value. So what this is doing is it's preventing you from having direct access to the DataStores.value key. And if we now take a look at the verify module, we can see this module has some functions. And what this function is essentially doing is scanning through a table, checking to make sure it's valid to be saved inside of the data store. And if we copy this test validity function and go back to DataStore2 and search for it, we can see that every time the save async function is called, it checks the save value which we cloned into here to make sure that it's valid. And if there is a problem, it will reject the save. So now that we have a rough idea of what the submodules are doing, let's now take a look at the most important submodule, which is the save methods. Now, I'm pretty sure that most people that are using DataStore2 are using the ordered backups method, but let's just quickly look at the standard method to see how it works. So this method essentially has two functions, get and set. When we use get, it's going to use get async to get the value using the user ID of the player. And when we use set, it's going to use update async to update the value for the user ID of a player. Now, for some reason, they've decided to use update async over set async. There is a misconception that update async is more secure than set async. But that is only true if you're using the previous value. So for instance, if I received the previous value over here and then updated the value inside of this function, for instance, let's say I wanted to add 10 coins to the value, now using update async would be more secure because it would prevent race conditions from multiple servers trying to adjust the value of this data store. But if we're simply just passing a value into update async, it's not more secure and you're just simply wasting a get limit for no reason. So let's now take a look at the ordered backups method. And in this method, we can see we have the same two functions, get and set. And we can also see that each player has a separate data store and a separate ordered data store. And inside of the get function, we can see the first thing it does is get sorted async, and it's going to get the values in descending order, which means from highest to lowest. And it's only going to get one page, and then it gets that one page, and it only gets the first value from that page. And then the next thing we do is check to see if that value exists. If it doesn't exist, we simply return nil. But if it does exist, we're going to update the most recent key with the value. And then we're going to use that value to use get async to get the data from the data store. And if we now take a look at the set function, we can see the first thing it's doing is getting the most recent key. Now, if this is the first time the player has ever logged in, this will be nil. So it's going to default to the value of 0 and then add 1. So if this is the first time the player enters, the key is going to be equal to 1. Then we use the value of 1 to set the value into the data store. And then we're going to use the set async on the ordered data store to save the key and also the key as the value. So the value 1 is going to be saved as the key and the value. And then we're going to set this key as the most recent key. So let me try to explain what's going on here. Each player has an ordered data store and a data store. And when a player logs in for the very first time, we're going to use the get function. And what this function is going to do is try to get the highest value from the ordered data store. But currently we can see there's no value inside of the ordered data store. So it's just going to simply return the value of nil, meaning that the player has no data. But after the player has been playing our game and we decide to save their data store, what it's going to do is first going to use the most recent key, which is currently set to nil. And we're going to add 1 to 0, which is going to set the key to 1. And then we're going to use that value as the key for the data store. So what that means is we're going to use the value of 1 for the data store, and we're going to save the value of whatever the data is. Then if this is successful, we're going to set the value of 1 into the ordered data store as the key and the value. So we're going to save the value of 1 as the key and 1 as the data. Now let's imagine that we use the set function a second time, this time to update the value again. What it's going to do is going to add 1 to the most recent key. And if you remember, we saved the value 1 from previously. So now the key is going to be equal to 2. Then it's going to use the value of 2 to set the value into the data store. So we're going to save it into a separate data store with a key of 2. And this is going to contain the most recent data, where this key is going to contain the previous data. And then we're going to set the ordered data store with the key which is currently set to 2. So we're going to save the value 2 and 2 into the ordered data store. And if we now imagine that the player has left the game and later on re-enters the game, we now must use the get function to load the player's data store. So what this is going to do, we're going to use the get sorted async in order to get the highest value from the ordered data store. And this is going to be equal to 2. Then we're going to set the 2 value into the recent key value. And this also gets set into most recent key. So most recent key is going to be equal to the value of 2. Then we're going to use the value of 2 to load the data store, which is going to get this value over here. And let's imagine that we now want to set the player's data store. Because the most recent key was set to 2 when we originally got the data store, now we're going to add 1 to 2. So now key is equal to 3. So we're going to save the value with the key of 3. So over here, we save it into the data store with the key of 3. And then we save the 3 value into the ordered data store. So we're going to save 3 into the ordered data store. And finally, set most recent key to 3. So what is the benefit of using a save method like this? And the answer is there is none. In the past, this save method had 2 benefits. The first benefit was that it would keep a history of all previous saves, allowing you to have versions and allowing you to back up to a previous version of a save. But now Roblox has built-in versioning. So Roblox, every time we set a value to a key, it will keep the previous version for up to 30 days. So what that means is, if I continue to set my value into key 1 over and over again, Roblox will keep all previous versions up to 30 days. Another benefit that this saving method used to have is, before, we could only write data to the same key once every 6 seconds. So in order to bypass that 6 seconds, by setting the value into a different key every time, we no longer had the 6-second limit. But recently, it looks like that Roblox has removed the 6-second write limit. So what are the downsides of using this save method? The first downside is we now have 2 points of failure. So what that means is, if we manage to save the value into the data store, but don't manage to save the key into the ordered data store, we'll lose the data from the data store. Because let's imagine we're currently on key 3 and we add 1. So we're going to save the data into key 4 and we manage to save the data. But now, as we're going to write the value of 4 into the ordered data store, let's assume that the ordered data store fails. So now we're still going to be on key 3 because the most recent key is not going to update. So we're still going to be on key 3. And when you call set once again, what it's going to do is going to set the value back into key 4 a second time. And then it's going to attempt to write the value of 4 back into the ordered data store. And if it succeeds this time, we'll now be on key 4. Another downside of using this save method is we're now using more set and get limits from our data store. So we can see that when we save, we are using 2 sets, and when we get, we're using a get sorted and a get. And if we look at the data store, we can see that we only have 10 sets per player and 10 gets per player. And one of the gets is a sorted get, and we can see that each player only has 2 sorted gets. So by using this method, we are wasting 1 of our sorted gets. Another downside of this save method is it's not able to support multiple servers interacting with the same data store object. So you may have noticed that when we create a DataStore2 object, we must pass in the player object. And this is because a player can only be in one server at a time, and DataStore2 does not allow us to pass in the player's user ID, because this would allow us to open the player's data store in multiple servers. But let's see what would happen if we did open the data store in 2 servers. What would happen is we'd first use get in both servers, and both servers will have the most recent key of 4. Then let's assume server A used the set function and set a new value into key 5. Now server A will be on key 5 while server B will still be on key 4. So if server B uses the set function, it won't be able to set the value into key 6 where it should go. It will just simply overwrite key 5, and now server B will be on the same key as server A. So we can see that if two servers do use this save method, that they would be fighting with one another and continuing to overwrite each other's data. But because DataStore2 forces you to use the player object, they will never have this problem where two servers fight over one another, because the player object can only be in one server at a time. Now, before we move on to ProfileService, let's first learn what session locking is. So both ProfileService and Suphi's DataStore uses a concept called session locking. So let's assume that this text file is a DataStore key. And let's assume that a player enters the game and that server uses getAsync on this text file. And now we can see that this player has no data in their data store. And let's assume that this server caches the value of coins equals 1 for this player. Now, if another server comes along and tries to open this data store key, that server will not see that the player has 1 coin. For them, it would look like the player has no data. And even if we use setAsync on this server, so now this value is saved into the player ID data store key, this server will still not be able to see it until it reopens by using getAsync on this key a second time. And now server B is able to see the correct value. And now if server A decides to increment the coins up to 2, server B will not be able to see this increment. And let's say server A saves, and then after server B saves, now if both servers close, whoever last saved is what's going to be inside of the data store. So now we can see that the player still has 1 coin, even though server A set the coin as 2. So this is where session locking comes in. If one server opens this data store key, what session locking will do is lock this key, preventing other servers from opening it. So if another server comes along and tries to open it, it's going to give an error saying that this session is locked and prevent you from opening it. Only once this server has saved and closed the session, now it will allow other servers to come along and open it. So only one server can have the data store key open at a time. And that is essentially what session locking is. So let's now quickly overlook ProfileService. So at the very top, we have a table of settings. We have a signal module, which is incorporated into the same module down to here. Then we have the ProfileService table, and this is the table that's going to be returned when you require the module. And these are some properties of that table. Then we have some private variables, and we have some private functions. And then we should have the global updates table, which you could imagine like a class. And these are the functions of this class. And if we continue down, we can see the profile class and the functions relating to the profile class. And we can see some other classes. And at the bottom here, we have the part that initializes when the module first starts. And we check if it's studio, and we do some stuff here. And we connect to the heartbeat event. And over here, we are connecting to the onClose event, which will be telling us when the server is closing. And this is what will happen when the server closes. So let's now see how ProfileService does session locking. What I'm going to do is press Ctrl F, and I'm going to search for saved profile structure. And this is going to give us this piece of text here, which is going to show us the DataStore profile structure. So inside of this profile, we have a data table, And this is where you're going to save your user data. And we also have metadata. And this is going to save information about the session. Now here we can see that we have a value called active session. And this value can be equal to a table that contains the place ID and job ID, or it could be equal to nil. And this is going to tell other servers whether or not this profile is currently active or not active. So what that's going to be like is, let's imagine that this is the DataStore key, just like before. And let's imagine a server wants to open this DataStore key. Now what ProfileService is going to do, instead of using get async, it's going to use update async. And that's going to allow them to first get, and then to read if there's an active session. And if it's not an active session, it's going to set the active session to a table with the place ID and job ID, and it's going to instantly save because we're using update async. And if another server tries to open this same key, it's going to use update async, and then it's going to read the active session. And if the active session is not equal to nil, or if the job ID or place ID is not equal to this server's place ID and job ID, it's going to exit without making any changes. But if the active session is equal to nil, or if the place ID and job ID is equal to this server, it's going to allow you to open this session. And once this server decides to release the session, what it's going to do is set the active session back to nil, allowing other servers to open the session. But we have a problem. What would happen if this server crashes or Roblox's servers go down and it was unable to set the active session back to nil? Well, this job ID is a unique ID that will never be used again. So this session is going to be locked forever, and no server is ever going to be able to open this DataStore key ever again. And this is where the last update value comes in. So here we can see we have a value called last update, and this is going to be set to the OS time. So let's now add this to here, equals OS time. So every time this server does a update async onto this DataStore, which should be every 30 seconds, it's going to set the OS time as the last update. And if we go up to the settings, and we should see that we have autosave profiles, and we can see it's 30 seconds. So that means that this is going to be updated every 30 seconds and update the OS time every 30 seconds. And here we can see assume dead session lock in 30 multiplied by 60, which is equal to 30 minutes. So what that means is if another server comes along and tries to open this session, so it's going to use update async on this DataStore key, and it's going to see that the active session is not equal to itself and it's not equal to nil. So it means it's locked, but at the same time, it's going to also check the last update, and it's going to cross-reference the OS time with its own OS time. And if the difference is greater than 30 minutes, it's going to assume that the previous server crashed or was not able to unlock it, and it's going to overwrite the session lock even if it hasn't been unlocked. And this is where we run into our first problem. OS time relies on the operating system's time, and this server's operating system and this server's operating system may have different times. And if we go to Google and search for Roblox OS time out of sync, we can see that there are many reports of people reporting that the OS time is different between servers. So in order to combat this problem, what ProfileService has done is they have assumed the session is dead after 30 minutes. And here we can see it says, as of writing, OS time is not completely reliable, so we can only assume session lock are dead after a significant amount of time. Now, even though we're using 30 minutes, to assume that a session is dead, we still cannot be 100% certain that two servers will have a delta less than 30 minutes. For instance, if this server is running behind by 15 minutes and this server is running ahead by 15 minutes, then this server is going to be able to overwrite this server's session even if this session has not closed. Another problem of having a timeout of 30 minutes is if Roblox servers only go down for a little while, and once the servers come back online, if a player tries to join your game again within a couple of minutes, the session will still be locked until a total time of 30 minutes, preventing them from playing your game for a total of 30 minutes until the session times out. And while the use of spin locks has no effect on the safety of the module, I personally am not a big fan of using spin locks. And at the same time, I'm not a big fan of using the heartbeat event. So let's now take a look at Suphi's DataStore module. So here we see the main part of the module, and within this module, we have some sub-modules just like DataStore2. And the main module is going to use these submodules to function. Now, if we first take a look at proxy, so the job of the proxy module is to sandbox the other modules. So what that means is if I create a script and if I require Suphi's DataStore module, and if I create a DataStore object, and now, if I set a property of the DataStore object, so for instance, if I try to set the lock interval to a value that is not valid, for instance, -10, and if I now play the game, we can see that the module gives us an error. It says failed passed value is less than 10. So now we know we must set a value that is not less than 10. And the next module we have is the signal module. And this module emulates bindable events. So it's a custom version of bindable events. And it's almost the same as how ProfileService has its own signal module, which is this part here. And we can see this is the signal module for Suphi's DataStore module. Now, you may be wondering, why does Suphi's DataStore module use a signal module when it could just use bindable events? And the reason why it needs to use its own signal module is because if we go into Workspace and look at the properties, here is an option to change the signal behavior, and we can have deferred or immediate. Now, Suphi's DataStore module is very time sensitive, so that signals need to be executed at specific times. And if I used bindable events, then if you set the signal behavior to deferred, it would break the DataStore module. So in order to not break the DataStore module, if you change the signal behavior, I've created my own custom signal, and this will always be immediate, allowing DataStore to never break even if you decide to change the signal behavior. The next submodule that we have is Synchronous Task Manager. Now, this Synchronous Task Manager is a tiny bit like Promise. So what this Task Manager will do is allow me to add tasks to run one after the other. But unlike Promise, it has many features allowing me to add tasks to the front of the list, allows me to add tasks to the back of the list, allows me to find a task from the front, find a task from the back, allows me to stop the tasks, and has many other features that Promise does not have. And this allows me to have very complex task management when using the DataStore. And let's now take a look at the Suphi's DataStore module. So at the very top, we have our private variables. We have our types. So we have autocomplete, and we can also use strict scripts, and it should work correctly. Then we have our constructor, which is going to be returned when you require the module. And we have the new function, the hidden function, and the find function, and a enum, which gives a list of strings. Then we have our DataStore object, which is like a class, and this is what the class is called. Here we have some shared values that are shared between all DataStore objects, and we can see the open function, the read, save, close, and destroy functions, and some other functions relating to the DataStore object. Then we have the set table, and when we try to set a value, for instance, if we try to set the lock interval like we did inside of this script, we can see that it first checks to make sure that you're setting a number. It checks to make sure that the value is not less than 10. And here we can see the same error that we got last time. Pass value is less than 10. And then once all the checks pass, it will set the lock interval of the DataStore object. And here we can see a list of the read-only values. So if you try to set any of these values, it will print this error over here. And here we can see our private functions. So here we have a open task. So what's going to happen is when you call the open function for the DataStore object, it's going to first check to make sure you're passing in a DataStore object. Then it's going to check the current state of the DataStore, and if it's set to nil, it's going to return that the state is currently destroyed. Then it's going to use the task manager to find a previous open task, and if it manages to find an open task, it's just going to simply wait for that open task to finish. So we're essentially batching tasks together. And then if we are unable to find an open task, it will try to find a destroy task, and if it finds a destroy task, it will return that the state is currently destroying, which means we can't do a open task at this current time. And then we check to see if the state is currently already open and that there is no closed task. And if that's the case, we're just going to simply reconcile the template and return success. And finally, if none of these are true, we're going to use the task manager to insert the open task to the back of the task manager. And then we're going to wait for that task to finish. And so here we can see the open task function is being passed to the task manager. And that is the same open task function that we saw down here. So what this open task is going to do, it's going to attempt to lock the DataStore key. And then if it doesn't succeed, it's going to return back to whoever's waiting for this task to end that it was not successful. Then it's going to load the DataStore. Then it's going to check if the load was successful. If it's not, it's going to return back to whoever's waiting for this task to end that it was not successful. Then it's going to change the DataStore state to true. Then we're using the task manager, and we're checking to see if there is a close task or destroy task. And if there is not a close or destroy task, it's going to start the timers for the save timer and the lock timer. Then we're going to loop through all the threads that are currently waiting for this task to end. And we're going to respond to each one, and we're going to reconcile each one's template, and we're going to return back to them with the response. And then we're going to see if we currently have the process queue set is not set. And then we're going to check that the process queue signal has at least one connection. And then we're going to defer to the process queue function, which is down the bottom of the script. And then we're going to use the signal module to fire an event to anyone who's listening to the state changed event, telling them that the state changed to true. So if we continue to scroll down, we'll see more functions that is used by the task manager. And here we can see functions that are not used by the task manager. So we have the lock function that locks the DataStore. And we have the unlock, which unlocks the data store. We have the load, which loads the values from the data store. We have the save, which saves the values to the data store. And then we have the start save timer, which starts the save timer. And we have a function to stop the save timer. And we have a function that gets called once the save timer ends. We have the same three functions, but for the lock timer. Then we have a function to process the queue. Then we have a function which detects when a connection is connected to a signal. We have our clone function, which is the same like how the ProfileService and DataStore2 has a clone function. We have our reconcile function. We have a compress function, which allows us to compress the data, and a decompress function, which allows us to decompress the data. And these are two functions that are used by the compress and decompress functions. And finally, we have our bind to close, and this is going to be called when the server starts to shut down. And finally, we return the constructor back to whoever required this module. So let's now go over some little differences between the modules. So I'm not a big fan of doing deep clones. So if we look in Suphi's DataStore module, you'll notice that the only times we ever do deep clones are if you reconcile or if you call the clone function directly. Other than them two use cases, clone is never used. And if we take a look at the other modules, if we search for deep copy table, we can see that it's used a lot more commonly over here. And for DataStore2, every time you set or get a value from the module, you're constantly cloning back and forth values every time you set or get a value. Another thing that's very important to me is keeping time efficiently. So if we look at the start lock timer function, all this is doing is using task delay to schedule the lock timer ended function to be called after a certain amount of time. And if we want to cancel the timer, we can simply call task.cancel to cancel the lock thread, which we saved over here. And in order to prevent the lock timer from drifting, we use OS clock, and this will ensure that the lock timer is perfectly in time. Let's now talk about how Suphi's DataStore module does session locking. So the first difference between ProfileService and Suphi's DataStore module is Suphi's DataStore module will use a generated GUID as a unique ID in order to lock the session, where ProfileService uses the place ID and job ID. So why doesn't Suphi's DataStore module also use the place ID and job ID? And the reason for this is ProfileService will not work correctly if you attempt to open the same session within the same server, where Suphi's DataStore module will work correctly if you attempt to open the same session in the same server. Furthermore, Suphi's DataStore module will even work correctly if you try to open a session within separate actors. The next way Suphi's DataStore module is different when locking sessions is instead of saving the lock inside of the data store, we save the lock inside of the memory store. Now, the reason we save it within the memory store is because now we no longer need to use OS time. And the reason for this is when we update async the memory store, we can set an expiration time. So if I set the expiration time to 5 minutes, after 5 minutes, this memory store will automatically destroy itself and it will be unlocked for all servers without having to rely on OS time. Another benefit of using the memory store is now we can use less limits from the data store. So if we look at the data store limits, ProfileService will use one get and one set when it opens the session, and it will use one get and one set when saving the session, where Suphi's DataStore module will only use one get when opening the session, and it will use one set when saving the session. And the reason why Suphi's DataStore module does this is because it uses a update async on the memory store instead. And the good thing about this is the memory store has a lot more requests compared to the DataStore. And another thing to note is update async on the memory store only consumes one request, where on the DataStore, using update async consumes both one get and one set. Another benefit of Suphi's DataStore module is that I can set settings for each individual session. So I could have some sessions save at an interval of 30 seconds, and I could have other sessions save at an interval of 60 seconds. And the benefit of this is now I can choose how many requests each session uses. So for some sessions that are very important, I can have them save more frequently and use more requests. And for some sessions that are not so important, I can have them save less frequently and allow them to use less of my requests. So let me now try to demonstrate how Suphi's DataStore module uses the memory store in order to do session lock-in. So what it's going to do is, let's assume a player enters the game and we try to open their DataStore session. Now, the first thing it's going to do is going to use a update async on the memory store, and it's going to use the unique ID, which we have the GUID set to, and it's going to check the memory store to make sure that no one else has locked the session. And if no one else has locked the session, it's going to save its own unique ID into the memory store. Now, it's going to use the lock interval multiplied by the lock attempts to calculate how long to set the expiration time of the memory store. So by default, the lock interval is 60 seconds and the lock attempt is 5. So that means 5 multiplied by 60 seconds is 5 minutes. So by default, the memory store is going to have an expiration time of 5 minutes, plus it's also going to add a 30-second buffer at the end, which we never use, but is only there for safety. And now what we're going to do, because the lock interval is 60, we're going to wait 60 seconds. So here's our 60-second wait. And then we're going to attempt to update async the memory store again and try to extend it for another 5.5 minutes. So let's extend it after 60-minute wait for another 5.5 minutes. And now this is our new lock time. Then we're going to wait another 60 seconds, just like before. And then we're going to attempt to update async the memory store, trying to extend it once again. And if we wait another 60 seconds for the next lock attempt, and let's assume that when we try to lock the memory store over here with update async, that Roblox servers are currently having problems and we're not able to extend the lock after this interval. So nothing's going to actually happen here. We're just going to deduct the attempts remaining down by 1, and then we're going to simply wait another 60 seconds. Then we're going to attempt again. If Roblox servers are still having problems, then it's going to simply wait again. Now on this next attempt, let's assume that it does succeed in locking the memory store. All it's going to do is add the memory store from here, and now we have another 5.5 minutes while the memory store is locked. And now we wait another 60 seconds, and let's try to use update async to update the memory store, and let's assume that Roblox's servers are having problems and we're not able to update the memory store. So we wait another 60 seconds, and let's say we still have a problem. So we wait another 60 seconds. We still have a problem. We wait another 60 seconds. And if we still have a problem, we wait one last time, which is our last attempt, because we have 5 attempts. And if we've used all 5 attempts and we fail to lock the session in 5 attempts, at this time, it's going to close the session and it's going to prevent us from going over into this buffer zone. And for the save interval, The save interval works on a separate loop, so it has nothing to do with how the memory store is working. So every 30 seconds, it's going to try to save. So it's going to wait for 30 seconds and try to save. Wait 30 seconds, try to save. Wait 30 seconds, try to save. And it's going to keep wait looping and trying to save every 30 seconds, irrelevant of whatever the memory store is doing. So it's just going to keep trying to save every 30 seconds. And then once the session is closed, it's no longer going to try to save. And the benefit of only having a session lock that times out in 5.5 minutes is if the servers crash or go down, now the player does not need to wait for 30 minutes for the session lock to time out, but will only have to wait for 5 minutes. And we can further reduce this time by adjusting the lock interval and lock attempts. Now, I do not recommend going down too low, but a value of something like 3 attempts and 30 seconds between lock attempts is probably the lowest that I would personally go. So hopefully this video has shown you some of the benefits of using Suphi's DataStore module. And if you have any questions, feel free to leave a comment down below.